In question 9, we're told the finite region R, as shown in figure 2, is bounded by the x-axis and the curve with equation y is equal to 27 minus 2x minus 9 root x minus 16 over x squared, where x is greater than 0. The curve crosses the x-axis at the points 1, 0 and 4, 0. In part A, we're asked to complete the table below by giving your value of y to 3 decimal places. Okay, so let's put this in the calculator now, and what I'm going to do is just set this up and put one of the values that they've already given me in. I do this just to check what I'm putting in here is correct. You don't have to, but all I'm going to do now is sub in 1 to start with. So let's go and put 1 in, so put my bracket up, we'll put 1 in, then we'll have minus 9 lots of the root of 1, then we'll have now minus 16 over now 1 squared. So what I want to do is I want this to show me that it's going to be 0, therefore I know what I've put in here is going to be right. So it takes an additional 20-30 seconds, but it will ensure that you're not now going to put in the wrong values. So let's start off with the 2, and we've just switched those over, and that's going to be now on here 6.272. So we can write now 6.272. So let's grab the pen up and 6.272. So 6.272. Okay, let's now do the next one, and that's going to be 3. So all we're going to do is swap this over. So let's do that. So that's going to become now 3. Then we're going to have 9 root 3. So let's put that in. And then we're going to have 3 now in the denominator right here. And that will give me now, and we want this to 3 decimal places, that's going to be 634. So 3.634. Okay, let's just check that's correct. So that part's done, and that's our 2 marks. In part B, it says use the trapezium rule with all the values in the completed table to find an approximate value for the area of R, giving our answer to 2 decimal places. So we're going to use the trapezium rule, and the informal approach is to say now that the area, so we can say R will be approximately equal to 1/2. Then we're going to consider now the change in the x-coordinates, which is going to be 1/2. We'll have the first, which is going to be 0, plus the last, which is 0, plus 2 lots of what's left added up. So 5.866 plus 6.272 plus 5.210 plus 3.634 plus now the 1.856. So that's what we're going to have, and we'll just evaluate this on a calculator. So let's go ahead and do that. What I'm going to do is just find this bit right here first. So we're going to have 2 lots now of 5.866 plus now 6.272 plus now 5.21, so let's put that in, 5.21, plus now what have we got for 3.634 plus now for 1.856. So that's going to give us now a total, let's have a look at that, 45.676. So we've got 1/4 times by 45.676. So just check I've got that value right, that's fine. And if we divide that now by 4, we're going to end up with 11.419. So 11.419, therefore we can say 11.42, and that's going to be now correct to 2 decimal places. So 11.42 units squared. Okay, we now need to find in part C, so we need to use integration to find the exact value of the area of R. Okay, so what we need to do is go ahead and integrate this. So what I'm going to do is just move this now. Let's see if we can move this and do the integral. So let's grab that and move that out of the way. We've done that part, and then we can look at this right here. Okay, so let's go ahead and look at what we've got. So just rewriting this now, what I'm looking for then, I can say that the area, let's write this here, R is going to be equal to the integral now from 1 to 4. We've got 1 to 4, and I'm just going to write this now as 27 minus 2x minus 9x to the power of 1/2 minus 16x to the power of minus 2, and we're integrating with respect to x. So let's go ahead and work this out. So we can say then R will be equal to, and what we're going to have then is the following. We're going to have 27x. Now, minus 2x, we raise by a power and divide by the new power, minus 9x to the power of 3 over 2 divided by 3 over 2. Then we're going to get now minus 16x to the power of minus 1 divided by minus 1, and this is going to be evaluated between 1 and 4. So let's go ahead and tidy that up a little. In fact, I'll just move this down, get rid of all of this, as we've already done that part. So let's get that out of the way. That can go just there. So what we're going to have now, I'm just going to tidy this up before we evaluate it. We're going to have now 27x, then we'll have now minus x squared. This is going to give me now minus 6x to the 3 over 2, plus now 16 over x. So subbing in now 4 and 1, let's go ahead and do that. So we're going to have 27 lots of 4 minus now 4 squared minus 6 lots of 4 to the power of 3 over 2 plus now 16 over 4. From that, we're going to now subtract away from here 27 lots of 1 minus 1 squared minus 6 lots of 1 to the power of 3 over 2, and then we're going to have plus 16 over 1. Now, I've written this out. In these exams, they're often quite picky and really require you to do that. So we can see on here that there are 6 marks to this question, hence why I've done what I've done. Usually I just evaluate that, go ahead and evaluate it, but as there are 6 marks and as it is the exam that it is, I'm just going to do this like so. So let's go ahead and evaluate now. So what we're going to have then in the first bracket, that's going to give me 108. So 108 minus 16, and then this is going to give me, what's that? That's going to be 8, that's going to be minus 48, and then we're going to get plus 4. So the first bracket now is going to give me 48, so let's write 48 on here. So let's go ahead and do 48. So the first bracket now is 48. Again, you might want to show that you're evaluating each of these, and then on the next one, let's do the next one. We're going to have now 27, so let's do 27 minus 1 minus 6 plus the 16. So what's that give me? That's going to give me 36, so minus 36. Let's put that in there. So therefore we can say that this is going to be 12 units squared. So there we go. I suggest you actually put these values in just to ensure that you're getting the total marks. So let's just go ahead and do that. Let's just put these in just to show. So it's going to be 108. So we've got 108 minus 16, and then we can have minus 48 plus 4 minus now 27 minus 1 minus 6 plus 16, just to ensure I'm getting all the marks, but that's our final answer. So 12 units squared is going to now be the exact area of R.